All right, so in 4.4, we're supposed to not do the limit process anymore, and we're supposed to dive in and start integration using the shortcuts. Well, we skipped the limit process. So this is more of the same of what we did in 4.3, but there's some additional little tricky parts in there, so that's what I'm going to focus on. So on number 1, consider the following integral. We're going to go from 0 to pi, which is from 0 to 3.14, blah, 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 blah. And on your screen, you'll be able to see that this is shaded in. Unfortunately, I did black and white printing, and so you're not going to be able to see that. So I believe all of these are shaded over from 0 to pi, but only one of them is the correct graph. So again, being lazy math people, I do not want to get out of graphing utility. If I substitute in a 0, 0 squared plus 1 is 1, and 7 over 1 is 7. So if I shove in a 0, it spits out a 7. The only graph that hits the y-axis at 7 is this one. Okay, so then the question is, once we know that this is the graph, do you have positive area? Do you have negative area, or do you have no area? Well, again, we are above the x-axis, so our area is positive. Okay, and then we've got a few. We're going to go for, ooh, wait a minute, I skipped one. Hang on, go back. We have evaluate the definite integral from 1 to 6 of negative 3v plus 3 dv. I'm going to come over here. All right, so I have going from 1 to 6 of negative 3v plus 3 dv. So we're going to integrate first. So this becomes a negative 3v squared over 2. Increase your exponent by 1 and divide by your new exponent. This is a v to the 0. So increase your exponent by 1. So it becomes a v to the first. Remember, we're going to ignore the plus c's. And I'm going to evaluate with a 6 first. So negative 3 times 36 should be 108, but I don't trust my brain. Negative 3 times 36 is 108. So I have a negative 108 over 2 plus, evaluate at 6 gives me 18. Okay, so I evaluated at 6. You always subtract and now evaluate at 1. So negative 3 times 1 squared over 2 is negative 3 halves, plus 3 times 1 is 3. And when I slap all this in my calculator, divided by 2 is, plus 18 is, plus 3 halves is, and minus 3 gives me negative 75 halves. So negative 75 over 2 is your final answer. All right, so what do we got? On the next one, this should be kind of sort of tweaking your brain. What I have is going from 0 to 2 of 8t minus 1 squared dt. And you'll remember when we were taking derivatives, I would have to FOIL this thing out first. Because I don't have the derivative of the inside, or the derivative of the inside is not 1. So that same general rule is going to apply. The derivative of the inside is not 1, so I got to do something else. When we get to 4.5, we're going to figure out a trick for this. But for right now, we're going to FOIL it. So I have an 8t minus 1 times an 8t minus 1. And when I FOIL that out, I get a 64t squared minus 16t plus 1 dt. So now all I've done is algebra so far. So now I need to integrate. So I get 64t to the third over 3 minus 16t squared over 2, which is 8t, and then plus 1t. And I'm going to take that from 0 to 2. Now here's some good news. When I shove in a 0, that's going to go to 0, that's going to go to 0, and that's going to go to 0. That will not always be the case, especially if you are doing trig. So be careful. Don't just assume that there's a 0, so hey, I can ignore everything. But what I have is a 64. T to the third, when I shove in a 2, is going to be 8. So 64 times 8 gives me 512 over 3, minus 8 times 2 is 16, plus 2 is 2. And then remember, if you shove in zeros, it just all goes to 0 anyway. So divided by 3, minus 16, plus 2, and then math, fraction, gives me 470 over 3. So that is the area under the curve of this parabola going from 0 to 2. All right, so on the next one, I'm going to set some of these up and let you do them yourself. I'm going to go from 7 to 8. And the setup I have is a 3 over x squared minus 1 dx. I'm going to rewrite this with a negative exponent so it's friendly. So I'm going to go from 7 to 8 of 3 times x to the negative 2 minus 1 dx. And then when I integrate, increase your exponent by 1, divide by your new exponent. That'll be a minus x. And I'm just going to clean this up a little bit. So this term goes negative, and that x belongs in the denominator, minus x. And I'm going to go from 7 to 8. So shove in an 8, I get a negative 3 eighths minus 8 minus, shove in a 7, negative 3 sevenths minus 7. And then you can do the math from there. Okay, you can't see. All right, so I got a couple more here. I have going from 1 to 5, or sorry, 1 to 4, not that it matters because you can't see what I'm looking at. 1 to 4 of u minus 5 over the square root of u du. So I've got variables on top and bottom. Do not do quotient rule. You are integrating, not differentiating. So I'm going to take this numerator and assign the denominator to both terms. So remember, if I could rewrite that as u to the first over u to the 1/2 minus 5 over u to the 1/2. So when I clean this up, I'm going to go from 1 to 4. U to the first over u to the 1/2 reduces to u to the 1/2 minus 5u to the negative 1/2 du, and now it's easily integrable. So u to the 1/2, increase your exponent by 1 and divide by your new exponent, which means flip and multiply. And then I have u to the positive 1/2 divided by 1/2 means times 2. So this becomes 2/3 of the square root of u cubed minus 10 times the square root of u. And we're going to go from 1 to 4. So if I evaluate at 4, 4 to the third is 64, and the square root of 64 is 8. So I get 2 times 8 is 16/3 minus 10 times the square root of 4 is 10 times 2, which is 20, minus, and then evaluate at 1. 1 to any power is 1 until you get to Cal 2. So I get 2/3 minus 10. And then do that arithmetic, and you're done. All right, the next one is going to be slightly tricky, and that's probably all we'll have time for on this one. So what I have is I have the integral from 0 to 7 of the absolute value of x squared minus 6x plus 5 dx. Now the issue is I have absolute values, which means any negative area that I generate needs to turn positive. So first of all, what do I have? This is a parabola that's x-intercepts. If I factor that, I get an x minus 5, x minus 1, which means my intercepts are at 1 and at 5. Okay, so here's a 1, here's a 5. And then I have a lovely little parabola. Okay, so over here, if I'm evaluating from 0 to 7, this is positive area, this is negative area, and this is positive area going to 7. Okay, so I'm going to have to do this. There's a couple of different ways to do this. I'm just going to do what kind of sort of makes more sense. I'm going to leave this as it stands. Okay, and so I'm just going to pull it out of the absolute values, and I'm going to go from 0 to 1 and from 5 to 7. So from 0 to 1 of x squared minus 6x plus 5, and then plus the other positive area, which is from 5 to 7 of the exact same integrand. And then how do we flip this thing? Because what I want it to do is to go up like this so that it's positive area. So between 1 and 5, I need to flip this. So I'm going to change the signs on everything up here. So from 1 to 5 of negative x squared plus 6x minus 5. So what I did was I multiplied through by a negative so that it would flip this up. So really what you're finding the area of is now looking like this. So we've taken all of the area and made it positive. Okay. So I'm going to do these two first. So x to the second becomes x cubed over 3 minus 6x squared over 2. And then plus 5x. And you're going to evaluate that twice. Once from 0 to 1. And then again from 5 to 7. Okay. So plus, and then x to the third over 3 minus 3x squared plus 5x, going from 5 to 7. And then you're going to need to add this area to it. So this becomes a negative x to the third. Can you see it? Negative x to the third over 3 plus a 6x squared over 2 minus a 5x. And you're going to take that, dadgummit, from 1 to 5. So evaluate this from 1 minus, evaluate at 0. Evaluate this at 7 minus 5. Evaluate this at 5 minus 1. And take all of those numbers and put them together. And that's the absolute value of this parabola. Okay, so I am going to leave that for a second. I'll come back and do some trig ones with you as soon as I figure out how to